And welcome to another video of Indian Forest Service means question paper of 2021. And today we will solve two questions. One is theory and one is numerical. So first one is explain the different types of cams and follower. So here is the classification of cams and follower. So let us see about followers. First one is based according to the surface of contact. So there is a knife edge follower, roller follower, flat faced follower and spherical faced follower. And here it is a figure. This is a knife edge follower. Looks like this. Roller follower having roller attached to it, and it is a flat face follower, and this is a spherical faced follower. Now in the exam what you have to do, you need not have to draw the figure if you have time, and so you have to draw by manually, not up to the scale or up to the accurately, but yes, it should be look like the cam and follower. Okay. And if you do not have the time, then just what to do, write down the name and write at least one or two lines about every cam and follower, so that will be also sufficient for it. Second classification is based on the motion of the follower, that means reciprocating or oscillating. Like here you can see here, knife edge follower or roller follower. When cam rotates, the follower will oscillate, sorry, reciprocate in the guide, so its motion will be reciprocating motion, so that is called reciprocating follower. Oscillating means what? This is the follower, one end is pivoted, and as the cam rotates, so the motion will be like this, the oscillatory motion, like this. So this is called oscillating follower. Next is the based on the path of motion of follower, that is radial follower and offset follower. Radial follower is what? See here, the line of action of follower, the line of action of the follower and the axis of the cam, axis of rotation of the cam is passing through the same line. That is called radial follower. And offset follower is what? Here you can see that the center line of the cam as well as the following line of the follower, that is at some offset, that is called cam with offset. So this is the classification of follower. Now in, if you talk about the classification of cams, so that is radial cam and cylindrical cam. Radial cam, this all here we looked at, this is called radial cam. And cylindrical cam is what? Here this is called cylindrical or a barrel cam, with here a slot is there in cylinder, and follower will maybe reciprocating type or oscillating type based upon the application. So these are the classification of cam and follower. Next, the numerical. This is the from Porter governor. I will write down the data and draw the figure also. So let us start. A Porter governor has equal arms each 300 long, pivoted on the axis of rotation. Okay, so we will draw the figure. One axis of rotation here. Okay, let me draw again. So here axis of rotation, and arms are pivoted on this 300 long. The mass of each ball is 5 kg, that means small m, that is mass of each ball 5 kg, and mass of the sleeve is 20 kg, that means capital M. The radius of rotation of the ball is 150 when the governor begins to lift. Here when the governor begins to lift, that means at minimum speed, rpm will be minimum. So here r1, that is called r1, is 150 radius of rotation of the ball. So corresponding height, that is h1, will be for n minimum rpm. And the radius of rotation is 200 when the governor is at maximum speed. That means if we draw the figure again, this is axis of rotation, this is arm, and this radius will be r2 is equal to 200 so this height will be h2, and this will be corresponding to maximum speed n max. So find the range of speed of the governor. So first of all, we will find h1 and h2 by Pythagoras theorem. So h1 will be under root 300 square minus 150 square. So here you will get 223.6 mm. Now h2, that will be under root of 300 square minus 200 square. So when you solve this, it will be come out to be the this will be come out to the h1 will be a 259.8 mm. Sorry for a mistake. 259.80 mm, and this is 223.60 mm. Now we will find corresponding speed, maximum and minimum. So minimum speed n square for Porter governor when the friction is not considered, okay, neglected friction. So 895 divided by h1, and keep remember the point that h1 will be in meter, though we have found on mm, but we have to solve, we have to put the value in mm. So that is 0.2598 m. Small m is 5 kg, capital M 20 kg divided by 5. So n minimum will be, here when you take the under root of this, so you will get 131.24 rpm. So just mark this or make a box on it. Now corresponding maximum speed for height h2, that was 895 divided by h2 into small m plus capital M divided by small m. It will be 895 divided by h2 is what, 0.2236 0.2236 in meter, and here 5 plus 20 divided by 5. So, and when you take the square root of this, so you will get maximum rpm, it will be 141.46 rpm. So now range of the speed was, range of this governor will be n max minus n minimum. So maximum speed is 141.46 minus 131.24. So your range of speed will be 10.23 rpm. So this is the answer, range. I hope you understand this. So this is all for today, and in next video we will see some beautiful questions. So stay tuned with us, and thank you for watching this video, and subscribe our channel for more upcoming videos like this.